Good morning, everybody. It's almost Thanksgiving, but this is an RC circuit that was part of an exam in previous years, and some of you yesterday asked me how to solve it, and I'm going to use the same steps as we did in class. If a circuit has only one storage element, in this case this capacitor here, there's no other inductors, and it's asking for Vc of t and then also the current through the capacitor. So this here is Vc of t with the plus on the top and minus here, and therefore following passive convention, this is the current through the capacitor. So I'm going to start by drawing the circuit for t less than 0, and in this case I'm going to leave the capacitor open, not in this case, every time. Capacitor open and inductor short if this were an RL. And also I don't want to write the use of t's, I want to interpret them. So before t equals 0, this power supply is turned off, so I'm going to leave this open. And this power supply is on, so I'm going to leave those 30 volts there. And then there is the 10K and another 10K. And then the capacitor. I know, not the capacitor. Of course, I want to leave the capacitor open, but I want to remember where the plus and the minus are. So this is the plus and this is the minus. And now this is also not there, but the 5K is there. That's a bad drawing. But anyway, the capacitor here is across the 5 kilo ohms. And then there is the 10K and the 30 volts. So I'm gonna redraw this to make it a little bit simpler. Am I able to redraw simpler? Let's take a look. So this 10K, I'm gonna put it here. And then this here is all the same node that's from this other 10K. And so this here is the 10K and it's the 5K. Is that true? This and this, great, yeah. And the 5K. And the other side of the 5K goes in between the two 10K. So hopefully this makes this circuit a little bit easier to see. And the capacitor is still here, the plus and the minus. So it turns out the 5K and the 10K are in parallel. Five times 10 divided by 15, and this is times K. So this is 50 divided by 15 is like 3.3 K. And now this here, the 5 in parallel with the 10, this is 3.3. This is still 30 volts. And this guy is 10K, which means this is 13K, and it's 1/3 of the voltage goes here. I'm sorry, 1/4 of the voltage goes here, and 3/4 go here. So the Vc of 0, I'm running out of space here, will be 30 divided by 4. Which is 7.5 volts, more or less. And I'm happy to make this a little bit longer if this is not easy to find. Now I'm going to draw the same circuit except for t larger than 0. So for t larger than 0, this is off, so I'm going to short this power supply, but this gets turned on. So there's going to be that 10K there. And the other 10K is going to be now in parallel with the 10K. Because the 30 volts were here and they are short. And they are shorted now. And the capacitor, now I do draw the capacitor this time. And I do draw the 10 milliamps going down, and I do draw the 5K. And here's the capacitor. Actually, I don't know how the capacitor, how big it is. I gotta find it. So this is the for t larger than 0. And I want to find two things. Number one, I want to find the RC. Actually, number one is VC of infinity. So again, I want to know what happens here for t tending to infinity, and the 10 milli, the capacitor looks like an open, and the 10 milli split to I5 and to this side here, which is actually the same sort of current, I1 and I2. So really the 10 milli equals I1 plus I2. But what happens is that these two here are in parallel. Is that true? That is true. So this is one node, the green node, all the way here. And I'm going to make another one that's the brown node. It's this guy. So actually the capacitor and these are all in parallel. So this side here is the plus of the capacitor, and this side is the minus of the capacitor. But the two 10 are 10K in parallel, which means these two currents here are the same. So I1 is the same as I2, which is 5 milliamps. And the 5 milliamps actually splits into 2.5, and here 2.5 milliamps. And 2.5 times 10K means this voltage here, V1, okay, V1 is 2.5 milli times 10K. V1 will be 25 volts, except that 25 volts is the wrong direction for the capacitor. So I was interested in a capacitor, let me go back to blue, the capacitor in the plus on the left side. So VC of infinity is minus 25 volts. Also, if this is too fast, let me know and I can redo it. Now what happens is I want to find RC for this particular circuit here. So I'm leaving the think the capacitor is open, and the RTH will be turning independent sources off. It's going to be 5 in parallel with 5. So if you see here, really the this pink node and the brown node are all the same. So if I keep painting this node, you're going to see that the 5K is in parallel with the 10K and is in parallel with the 10K. So the RTH for the circuit for t larger than 0 is 2.5K. So finally I find RC. Of course I don't know what the capacitance is. So I'm gonna say the capacitance, if the capacitance is, let's say 20 millifarads. So then RC is 2.5K times 20 milli, which is 25 times 2, it's 50 seconds. So that's tau. And now finally I can write the answer, and I'm gonna follow this here. VC of t is VC of infinity minus 25 plus 7.5 minus 25 e to the minus t divided by 50 volts. So this is VC of t, which is half of the question. The other part of the question is what's IC, and then I'm gonna just do C dV dt. It's also IC of t, and my capacitor here is 20 milli. I don't know if on the homework assignment it was the same. And now I will do the derivative of this. So the derivative of minus 25 is 0, and this here is minus 2017.5. So it's going to be minus 17.5 times minus 1 over 50, which is the derivative of this exponential here. U of minus t over 50 amps. IC of t will be, oops, it's 20 milli times this. Okay, 20 times 17.5 divided by 50, e to the minus t over 50 milliamps. So the milli from here, I took it out, so 2/5 is 0.4. IC of t will be 0.4 times 17.5 will be 3570 maybe. 0.47 e to the minus t over 50 milliamps. Of course, I am aware that I may have made many math mistakes here. I told Julian the other day that I did not pass circuits because of my math mistakes, but I promise you that's the method. This is the method to actually solve the circuit. I hope this helps.